Okay, so on the topic of cloud computing, it's a new hot field. So we'll talk about what is cloud computing, and I guess what we'll talk about is what is a cloud, what is computing, and we'll put the two together. We'll know what cloud computing is. And some of the stuff that goes on behind the scenes, like the SQL. So we're going to store our data somewhere. We could use SQL or we could use no SQL. And then a lot of cloud computing is high-speed retrieval of data. So very popular is the RAID systems. So we'll cover those. And so we have a question, what is computing? So if you were asked the question, what does it mean to compute something, what would you say? Any, somebody, you have a degree in computer science, and someone said, what does it mean to compute something?
Basically precise calculation of information.
Yeah, so,
Process that.
yeah, so basically you're taking some type of mathematical operation, you're trying to compute a result, and there's steps along the way, and sometimes you take numbers, perform a mathematical operation, you get some temporary values, which are then going to be used in a later step. So a simple example could be trying to solve something like 5 plus 3 times 4. So if you're going to solve this and you're reading from left to right, you read the 5, you read the plus sign, you read the 3. Do you add the 5 and the 3? Would you add the 5 and the 3 if you were solving this?
Multiply that.
No, it'll be 3 times 4 where we'll go.
Yeah.
Right. So because multiplication has higher precedence than plus, you would wait. And you would do this operation first. Get this result, 12, and store it somewhere. It's a temporary variable. Store it somewhere. And then later do the 5 plus the result of this one. So there'd be a lot of, so there's actually a lot involved in the thinking of just doing this simple computation. So we'd skip over the 5 and the plus, and we'd record 12 in temporary storage. Then we add 5 plus 12, and we get 17, and that's the end of our computation. So if you're doing this on paper and pencil, you're doing a computation. If you were doing this electronically on a device that can record numbers and perform math and, add and multiply, that device would be called a computer. An electronic device that can do computations is called a computer. Okay, so that's computing. So now what is the cloud? Okay, so what would happen if, so this is a picture, I should have got a better picture of this. This is supposed to be a phone. Does this look like a cell phone?
It looks like an iPhone.
Yeah.
A small life?
Yeah.
An iPod?
Like just a very old iPhone.
Okay, all right. Maybe I should have got a more modern one. Well, what would happen if you spilled a cup of coffee on your phone and it fried the phone? What would happen to all your pictures and your friends' contact phone numbers? What would happen to all that stuff?
Basically gone.
It would be gone if
If you
All-
did back it up.
the storage is all on your phone.
Yeah.
And then the phone got destroyed, it would be gone.
Yeah.
But what if you copied all the data that's on your phone somewhere else? Then you could go buy a new phone and download all the data onto the new phone. Nothing gets lost, right? So where would that somewhere else be? Well, you ever go home and they give you a wire, you could plug it into your laptop and copy everything over?
Yeah.
You could save it there. But if you did it through the internet, just saved it, and even like every time you took a picture, it made a save of it automatically, then that storage, wherever you saved it, could follow you anywhere you go, like having a cloud over your head. So that's why they call that the cloud. The cloud is a place outside of your cell phone or your laptop where you can store things. And when you store them, you could then from somewhere else download it. So that's really all the cloud is. So there's nothing too fancy about what the cloud is. It's just a place outside of the storage where you can put things. Okay, so data can be uploaded to the cloud from computers and cell phones, and then you or other people can get the data at some later point in time. So we have all these people loading stuff up to the cloud, and then these people read it. Could be the same people, could be different people. They all look like different people in this picture. Whoever put this up, feature picks. Okay. So what is the difference between client-server computing and cloud computing? Client-server you've been doing your whole life.
Yeah.
You log into Facebook, you're doing client-server. You're the client, Facebook's the server. So you're logging in from somewhere in the world. Maybe you're even on a local area network and you're going through a firewall out to the internet, either your organizational intranet or connected to the internet. You connect to a server. The server has a processor on it, or maybe many processors, running computations. And the server can read and write from a database as it's doing its computations. So if you do 3 times 4 and you write the result of 12, you could write it there and come back later and finish your computation. When the computation is finally finished, the answer comes back. So it could be many examples. This could be a Facebook server. This could be you're trying to log in. It'll look through the disk drive for all their users. Look for your email address, see if the password you typed in matches. If it matches, it'll let you in. And the results of the computation get sent back to you. So instead of your computer and your disk drive in your house doing the computation, the server's doing the computation. You're just connecting to it and they're doing all the work and then the answer comes back. So that's client-server. So isn't client-server computing the same as cloud computing? What's the difference? It's somewhere else. If you were here and connected to Facebook, and then you got in your car and you drove over to here and connected to Facebook, that's kind of like what we're saying cloud computing is. It follows you wherever you go. So what makes the difference between client-server and cloud? And the main difference, and it's kind of subtle, is utility. So what is a utility, right? So like the electric company, the water company, the gas company, those are called utilities. Why are they called utilities? Why are they called what makes something a utility? Yeah?
What's something you see using in your life daily? You
Yeah.
utilize, like you're basically using a certain item or tool for its intended purpose. So let's say like tools you use to build stuff,
Okay.
or the things
Yeah, that's kind of
word
what-
on the belt,
You're
utility.
thinking
belt.
a utility belt.
Yeah,
Okay.
so like they utilize that to like access their tools.
Yeah, so it's that's a good point. A utility belt. Those are the tools that you have and you use them when you need to, I guess. But and the main difference is if you pay a fixed price, like if you pay $100 a month for water at your house, that's not really a utility, because whether you drink nothing or you use tons of water, you're paying $100. But if you pay every time you use it, you get a glass of water, that adds to your bill. That's a utility. You're paying it every time you utilize it. So that's technically the difference. And the main difference between client-server computing and cloud computing is it's a utility. Cloud computing is a utility. So you pay as you use it. So client-server versus cloud computing. Client-server, you buy the server computers. You can buy them and put them in your house if you want to, or you could rent them from GoDaddy or Network Solutions. You pay for an IP address, so you go to your local Fios or Comcast, and you buy an IP address. Then you make the connection into your computer. Turn your computer into a server, start serving up web pages. You buy the disk space, which has to record all your customers. If you're an e-commerce business, you have to store all your customers' orders, shopping carts, and that kind of stuff. And then you pay a fixed price whether you utilize the resource or not. This is called hosting a website. That's where you pay a fixed price and then you can host it as much as you want. Actually, it's a little deceiving because if you start having too much traffic, they'll start charging you more money, even though they're charging a fixed price. But with cloud computing, you pay for the disk space and the processor's time and multiple IP address if needed as you grow and shrink, and you pay for it as you need it. So every month you get a different bill, kind of like the electric company gives you a different bill. So, how would you then access the cloud? So you don't have a direct connection to the server to store your code, data files. So how do you access it? You access it from your PC or from your phone, anything that can connect to the internet. So for example, if you have a Gmail account, you don't care where the server is, just anywhere you go in the world, you want to be able to connect to it. It has to be reliable, and you'd be happy with that. Okay. So there's a front end and a back end to the cloud, and the front end is your computer or your connection to the internet. So the cloud, the service, whoever you use, whether you use Amazon or IBM or Microsoft, many companies now provide cloud services, they will connect you to a controller node. The controller node can be connected to many servers, and it can be connected to some or many disk drives. This disk drive is strange, it looks like a refrigerator almost. But anyway, and then the disk can be connected to multiple computers. It's really the cloud services call if they want to do that. And so if you're doing a computation, the computation could be reading and writing from memory. It could be split up among many processors. If you're doing something that's very intense processing, the cloud company could decide, since you have such a big computation to do, they'd like to speed it up by spreading it out among many processors. And they could all have separate connections to the database. And then these application servers will eventually give you your answer on an as-needed basis. Okay. So some of the advantages to cloud computing is scalability. So if you started up a website, and the website started having a lot of traffic coming into it, you might have to get a second IP address and split up your traffic. And that's kind of complicated to do. So it'd be good if the cloud company would just do that for you. It started to notice your traffic built up too much. So as your product is scaling, they could give you more IP addresses, more processors if you're doing a heavy computation, or more disk space if you happen to have some kind of a website where your customers are logging in and just uploading more and more storage. And you have instant access to more or less computing, so however many processors you need will grow and shrink, and as you use processor time, they bill you for the time you used on their processors. So generally you save money. Sometimes you could lose money, but generally you save money. So you pay for what you use. So your company doesn't have to provide software on all of its PCs. You could actually have the cloud hosting company provide copies of Excel and PowerPoint or whatever you need. Have you guys ever used the one here at the university? Have you ever used Excel?
Mm-hmm. Yeah.
The one that, so it's Google does it, right? Who supplies it? Google?
I think it is Google now.
Microsoft.
It is changed to Google.
Oh, okay, because I know that they sometimes allow students to also download the program with their.
Yeah, but so the idea is if you had a laptop or even on your cell phone, if you don't have Excel, you could download an Excel document, make.
What do you mean that way? Because it's not Excel's on the computer. It's not Microsoft Excel.
Okay.
I actually.
All right, it doesn't really matter. So the point I'm trying to make is that instead of you having 10 computers at your office and everyone has to have Microsoft Office on it, if your cloud company has it, you could use it on a per-use basis.
Yeah.
Okay. So that could even save money, licensing of products. Also, you buy, Microsoft 2007, and then so many years later it's outdated, and you have to buy an upgrade. So they'll just keep you to the latest upgraded version.
As a cloud-based.
So, right. So then, and then there's no physical space needed for processors or disk space. That's another advantage. You don't have to fill up a room full of disk drives and processors, and then have to worry if there's an electrical outage. You have to have a backup in maybe another state or another country. So and you don't have to hire an IT guy anymore. The guy who comes and fixes the computers. But obviously the cloud company is going to have to hire a few IT guys to fix all.
On their end.
Well, yeah, on their end, right. So okay. Some of the disadvantages. The biggest disadvantage is right now obviously security. So if you had secure customer data for your app, And if it was in your basement, if nobody could get into your basement, and through either break into your basement or through a firewall, your data is secure. But now if you put it on the cloud, some other company, like Amazon or Microsoft, has all your secure data, so you have to count on them to be secure. So security and privacy is a problem, and usage fees. So this would be, if you ever had one of your customers just overuse your product, right? You're gonna pay by usage. So now that you're open up to, not so much cyber attacks, but just money wasting attacks. Because rather than you paying a fixed fee, $100 a month, and then if the usage went way up, your company might call you up and say, hey, you have to buy a bigger plan, something went wrong, and then you can investigate why it went wrong. Whereas if it's on a usage basis, you could have a really bad month and you get a huge bill. The other thing is sometimes they'll have bandwidth caps. So if too many people are using your server at once, they might just offer you more IP addresses and more servers and route the traffic into different servers, or they might just stop it and tell you, pay more money and we'll do it for you, rather than do it without asking. Okay, so the cloud comes in a few flavors, and there's the public cloud, the private cloud, and then kind of a mixture of the two. So public cloud resources are available to the public for a fee. Public cloud is connected to the public internet, and public cloud costs less than a private cloud. So sometimes the public cloud, you could be on a server that 5 other customers are sharing the same server, same processor, and you could be sharing time with them. You could have your data put on a disk drive that also has data from some other company on the same disk drive. So obviously the hope is you can't read their data and they can't read your data. But if you decided that, and some examples of companies that do this are, I have a bigger list after this, but Amazon and Rackspace are the 2 biggest ones offering a public cloud. You can also have a private cloud, which is going to cost more money. But so private cloud has the same capabilities, are available through private networks or the internet. Big data and data science applications are typically run in private clouds. So if you had your customers' data, let's say you were an e-business, and customers fill up their shopping cart and they buy stuff and then they check out, and you wanted to say, of all my customers, which ones, the ones who buy a certain type of a product, they're more likely to buy some other product, so I could then advertise to them. So you're going to now go through all your data of all your customers, and you're going to complete some data science statistics about them. You don't want that on a public cloud, because then other companies could access your customers' private data. So you typically do your big data or science data, data science, on the private cloud. And then a lot of times, since it costs more money, and some of the things you do need to be on the private cloud and some things don't, you can do a hybrid of both. So it's basically a mixture of the public and private cloud. So typically applications run in the private cloud and will jump out to the public cloud when there's too much traffic, what they call cloud bursts going on. So the trade-off between the two is cost and security, are the 2 things you want to consider. And determining where you want to put your application, public cloud or private cloud. Okay, so this is a list of some companies that offer cloud services now, and the list will be growing and growing. And so it's like Rackspace and then Amazon Web Services, AWS, are probably the most popular ones. So where did you say you used AWS? Was in another course?
Yeah.
Okay. And there are student copies of it for free? Isn't it?
Yeah. You have to verify that you're like a student through this school, and then.
Is it you just need an email that says
you need an email. Yeah.
That's it, right?
Or student email, because
Then they'll call you and you have to verify. That
They'll
it's
call you?
actually, Yeah.
Oh.
Yeah.
Really?
Wait,
It's like the robot. You just have to verify.
Oh, okay, all right. All right. So, and it's good for 1 year?
Yeah, it's good for 1 year.
Okay,
After that, they have to, pay.
Honestly,
okay.
what
Well,
doesn't Amazon
so
do
that's
now?
good for everyone to know that if you have, so you just need an email that ends in .edu,
Yeah,
and then you get a robocall,
yeah.
and then you have a year's worth of AWS.
Just to verify, and then
Okay,
There's a lot that a single email will get you.
yeah, yeah. No, that's good, a year's worth of AWS, so, all right. So, that's good for any students who don't know that. All right. So, when your application is connecting, your applications are up here in this picture, your applications are connecting to your storage. There's 3 ways it can connect. One way is where your application connects to a network, and then from the network connecting through a file system to get to the disk drive. The file system can be used for indexing and finding stuff faster, but it can also get in the way and slow things down if you want to connect directly. The network could distribute the work that you're, the way you're connecting into the storage, which again could save time, if it makes sense to do that. So all 3 types are available. There's the NAS, which is the network attached storage. So the application connects to a networking system, the networking system then goes through a file system to the disk drive to get the data you need. The SAN, which is the storage area network, is connected to the file system. The file system can then get through the networking faster, and the networking could then connect directly to the storage. Or you can skip the networking part and just go directly to storage through a basic file system. And that's the DAS, the directly attached storage. And that can be connected through, a SCSI connection. Okay, so as far as using processors, it scales. If you need more processing, they will give you more processors. But your computation needs to be able to be done in parallel. If it's sequentially, you're stuck with one processor. So really, cloud computing, there's 2 things we said at the beginning. We said that you're processing, you're doing mathematical operations, and you're also reading and writing to storage. And you're doing this in the cloud, not on your device. So this is just an example from a database application. Have you guys all taken a database class? Okay. So in your database design, you have an SQL database. And it's a collection of tables and then the connections between the tables, right? So in an e-commerce business, you might have a customer table. And the customer table would have an email address as usually what you're logging in with, the password, a name, country if you want. And then we can have carts and orders. So customers have orders and then they have carts. Sometimes you can have 1 cart, but sometimes you have multiple carts. You ever go to Amazon? You put stuff in your cart.
Yeah.
And do you ever put stuff in your cart that you're not sure if you want to buy? You just throw it in the cart. Maybe in a week from now you'll buy it.
Yeah.
All right. So it's just you're using it as a reminder, right?
Yeah.
But that's not okay. So sometimes they'll have multiple carts. Depends on the application.
There's no saving stuff.
What's that?
Like you save this item and it's added to
Yeah,
this
you can
list.
put it on like a wish list.
Yeah,
Yeah.
it's a wish list and a shopping list or something like that.
Okay, meaning you might want to buy it in the future, right? But yeah, a lot of people just throw stuff in their cart and then they don't buy it until maybe later. Okay, so anyway, then you can have cart items, and there's a connection between customers and cart items. You could have orders that, things that you bought, and then these are all the products that they have. So a customer might start grabbing products and a quantity of how many products, and might start putting them into a cart, and then once that cart hits a certain point, they do a purchase. The purchase then becomes an order, and then the order items have a connection to the products, and then categories of the products if you want to do searches on. So you might have a database laid out something like this. This would be an SQL database. So really what I'm talking about in this case is, so suppose you had an order. How would you handle this? Suppose you had an order, you bought an item, and the item had a price. So we have a total price. The product has a price field, right? Now, what if you bought something while it was on sale? Or what if you bought something and later its price went up, right? So let's say you bought something for $100 and then the price has gone up, it's now $125, and you decide to return it. So it's now $125, you bought it for $100, how much should you get back if they were gonna refund you your money?
They're only give you back whatever you paid for.
Right, but if you laid out your database, where's price? Price. If there's one price field for this item, and you bought it a month ago, and then you return it today, where would we go to know what you paid a month ago? If we went to the price field, it's been updated, so we think you paid that a month ago. So what can we do? Do we have old price and new price? Do we have dates when the price changed? Do we have a big log of, right? So this is this opened up an issue that if you lay out, this is kind of a common design for a database in our storage, but as people are doing things like buying orders, the orders could change. Or what if you bought something with a coupon? You get a 20% off discount, right? So you have an electronic coupon, you type in, I'm a student at a certain college and you get 20% off. Well then if you return it, you shouldn't get the full price. So we need to record everything about your transaction. The date you bought it, what coupon you used, we have to really, we can't count on these fields when you buy something. So if you buy something, what do we have to save? We have to pretty much save everything about your purchase. And we don't have tables for it. So what's the solution for it? If we save everything, right? So here's kind of the interesting question that comes up. In SQL, we have tables, let's say like customer, product, order. We had a few other ones, but those are kind of the main ones. So suppose if customer, I put a little C in front of these are all, ID fields. Customer 431 bought 1 of product 22 and 2 of product 523. Just numbers for our products. On March 2nd of a particular year, what table do we record the following fields in an SQL database? The ship to address, that would go in the customer, right? It'd have a ship to address. But you ever buy something, let's say you have your ship to address as your normal house, but you buy something for a friend, so you change the ship to for that one, but then you want to go back to your old ship to. So we don't have we're not going to save 2 ship tos, so we have to record for that particular purchase it's shipped to someone else, right?
Yeah.
So the product description, where would that go? The product description would go in the products table. The quantity of each product bought, that would go in your orders. The price of the product, that would, like we said last time, that was in the products table. Okay, so if the customer used an online coupon, where would you record that? We don't have that. We don't really have it. So what if there were 2 shipments and you return 1 of them? So sometimes you order 5 things and 2 of them are ready, so they send those 2 out in 1 package, and then the last 3 come a week later. And the question is, do we record that? Because all we have is the ship date. We don't have ship date part 1 and ship date part 2. So there's too much information can just keep getting split, and we have to really record all of it. Can't really do it in tables. So what can we do? Save the whole receipt, everything that happened on that shipment, right? So, if we're going to use a NoSQL database, not an SQL database, but a no, I mean kind of the opposite of it, even though they do use tables and SQL statements. The idea is that the information about every order grows so much that we have to really record everything that happened, and that you can't really put it into fixed size tables. So, same example, if customer 431 bought 1 of product 22 and 2 of these on March 2nd, what table would record the information? We would record all of the information in the order, let's say document 999. We would create a document, which is kind of like a whole printout of the receipt of everything that happened, and we just record it in all those fields. Now we could take that, like using JSON, we could have specific fields where we write out variable length data as needed. So kind of like XML almost. We'd like to record stuff where we could do searches on it, but we're gonna just record the whole thing in a document. So in a relational database, we have our database. Our database is made up of tables. Inside our tables, we have rows in the table, and then each of the rows are broken up into columns. So this is kind of a subset of what's inside. In a Mongo, which is, have you heard that expression, Mongo database? No? So Mongo is short for humongous.
Oh, wow.
That's what, so.
Okay.
So,
What a name.
yeah, so they call it Mongo database. So they took like the middle letters of humongous out. So you have a database, and it's made up of, instead of tables, it's made up of collections. And the collections are documents. So we record whatever we need to record. You used a certain coupon when you checked this out, and then we took the order and had two ship-to addresses, and we split the order up into 2 points. And then if you return some of the merchandise, but not all of the merchandise, we can make a second document showing that. And then each of the documents can be, like I said, using an XML type of, JSON type of field identifiers. We could cut it up into fields, so if we ever went to a particular receipt and we just wanted to see where did you ship it to, we could find that field in the document. Okay, and then, yeah, I think the last topic we'll cover is different ways for storing storage. Now that storage is getting much, much cheaper. And suppose you had many, many documents in a NoSQL database, many, many documents for all your customers, all the purchases they've ever made. And we want to look through all the purchases and say, oh, the customers who buy this item usually also buy this item too. So we have to go through all these documents very, very quickly. And not only that, the amount of storage for documents is going to be a lot more than if we just had tables. If we had tables, we only have one price for every item we've ever sold, right? It's in the price column. But if every time someone purchases something, we have to record that price, because the price could keep changing, then every time we make a purchase, we have to make a record of a price. So a lot more data this way, but the good news is storage is getting cheaper. So one of the things that is now becoming a big issue, because there's so much storage out there, and your cloud company, like Amazon or whoever you use, they want to save all of your storage for a fee, but they want to save your storage. Very likely, you're going to be searching your storage very quickly. So if, let's say, for example, Facebook, a customer goes to log in, you have a disk drive of all your customers, all your email addresses. So you type in your email address, you want to do a search on it. They're going to have to search everyone looking for a match. Chances are they'll use indexing to help find it faster. But they have to search disk drives very, very quickly, and there's lots of data to search. So we'd like to be able to search the data faster. So what can we do? Well, if we had 8 blocks of storage, rather than put it all on one disk drive and search it sequentially, why don't we get 2 disk drives and put half of your data on one drive and half on the other? So if we wanted to search all 8 blocks, we could search 1 and 2 simultaneously. Then if we don't find what we're looking for, 3 and 4 simultaneously, 5 and 6 simultaneously, 7 and 8 simultaneously. And if we're going through all the blocks, counting up how many times, somebody bought AA batteries, we want to know how many times did they buy AAA batteries. We'd have to go through all your orders. So by distributing it across 2 disk drives, we could do it in half the time. Obviously, 4 disk drives in 1/4 of the time, and this goes on. So they call this RAID is for redundant array of independent disks. So the version of RAID 0 is where you take your data and split it across 2 disk drives. Now there's really nothing redundant going on here because all the data is unique. So they should actually call this one AID, not RAID. It should be AID, right? Array of independent disks version 0. Maybe they mean 0 meaning canceling out the redundancy part.
Yeah.
Okay, so maybe it should be A0 instead of RAID 0. Okay, so the next version would be, now you're worried about losing your data. So if you're worried about losing your data, instead of having one copy of it, you make 2 copies of it. That way, if one of your disk drives crashes, you lose this whole disk drive, well, you got another copy of it. So you might want to stop, don't let customers make new purchases, or don't change the data. Get a new disk drive, a replacement one, copy all the data over, and now you have another backup, right? So by buying however much data you have, if you buy twice as many disk drives, you'll have a backup of everything. Okay. So now the question becomes, let's see, anything interesting here? So the blocks of data are striped across 2 disk drives and duplicated. We could do faster searching, because I got one disk drive read 1 and 2, while the other disk drive is searching 3 and 4. So I could still have the same, double the speed of my data, but I have to buy 2 disk drives to cover all of my data. The reason why I want 2 is because I want to have them backed up. In case I lose a disk drive, I want to be able to get all my storage back. Okay, so then the question becomes, is there any way we could not have to buy twice as many disk drives and still back up everything in case a disk drive failed? Okay, so then comes along RAID 5. So RAID 5 is basically wants to give us the ability to have a backup of our storage in the event of a disk crash, but we don't want to maybe buy twice as many disks as we need, maybe a little bit less on the backup. So the idea is, if our data is, in this case, block 1A, 1B, 1C, 2A, 2B, 2C, 3A, 3B, 3C, 4A, 4B, 4C. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 12 blocks of data, 12 blocks of separate data. If we put them across 4 disk drives, then, so the 4 disk drives take up 16 blocks of storage. Our data is 12 blocks, but we use 4 extra ones in case we lose a disk drive. And here's the technique. So we're not doubling our amount of storage, we're just adding 1 additional disk drive. So if we have a block of storage 1A, and we have a block of storage 2A, and a block of storage 3A, then we're going to have one block we're going to call the parity block. And the way this is going to work is, and I'll use a really simple example. Suppose all of our data is always bits, zeros and ones, right? If it could be a movie or a picture, it's always going to be made up of zeros and ones, right? So suppose our first block is, I'm just using 4 nibbles, 4 bits to represent. So here's some random data, 1, 0, 0, 1. So let's say that's the data in this block. And then this one, random bits, 1, 0, 1, 1. And that's the data in this block. 1, 1, 0, 0, that's the data in this block. What we're going to do with this parity block is we're going to, it doesn't really matter how we do this, but we'll put a bit here that makes the total number of bits across that stripe even, let's say. So this is 1, so I'm looking at this bit, this bit, this bit. The first bit on all of these blocks. Then my first bit in my parity one will be either a 1 or a 0, which will make the total even. So if this is a 1, this is 2, this is 3, I should make this bit a 1, so now I have 4, and 4 is an even number, right? 0 plus 0 plus 1 is 1, so I should make that bit a 1, so I have 2, 2 is an even number, so I put a 1 here. 0 plus 1 plus 0, that's 1, so I should make it a 1 to get 2, which is an even number, so I put a 1 here. And then I have 1 plus 1 plus 0, that's 2, so that already is an even number, so I'll put a 0 here, right? So these bits just make each column become an even number, right? So here's the idea. Suppose I lost one of these 3 disk drives. So you pick one, right? So it'd be like, Monty Hall. Door number 1, door number 2, door number 3. Pick one.
Number 3.
Yeah.
3? All right. Let's say I lost this disk drive, right? So this data is now gone. So I don't know this anymore. Can I figure out what this is from reading this and this and this? Well, this was a 1, this was a 1, and this is a 1, so this one must have been a 1, right? I know that's a 1. I can get it from the other 3. Now, this is a 0, this is a 0, this is a 1, so this must have been a 1. So that's a 1, right? So in other words, I can repair the lost disk drive, right? So that's the idea. So instead of doubling my storage, I just put this one parity block across each one. So 3 blocks of data needs a 4th one to cover the recovery parity bits. Okay. So, then people start arguing, right? So when you get on an airplane, there's 2 pilots. Why is there 2 pilots? In case one has a heart attack.
Yeah, well,
Right? One has a heart attack, right? First question people ask, what if they both have a heart attack, right? Never, so far it's never happened, but it could happen, right? Well, storage is getting cheap, so we can decide to be extra safe. We can have 2 parity bits, right? So now I have my data, one version of the parity. I could use the other, I could repeat the parity or flip the bits over, either way. This one makes them all even, this one makes them all odd, it really doesn't matter. But the point is, I can now lose 2 disk drives. I could lose this one and this one, and I can still rebuild the whole thing. So I can handle 2 crashes at the same time. So, but this one is actually, so all of the cloud companies, they do all of this for you as needed. One of the things you're paying for is you'll never lose your storage. How they do it is, it's kind of their business, but you might even ask them to do it this way. But a lot of them were using RAID 5. Now RAID 6 is very popular. So I don't know, maybe sometimes there weren't 2 disk crashes at the same time. And they said, oh, RAID 5 is not handling it, we have to do RAID 6. So, let's see, anything interesting here? The blocks are striped across many drives for fast searching. So yeah, if I want to search my data, I can have 5 different drives searching at one time. So this one's searching 3, this one's searching 2, this is searching 2, this is searching 2, this is 3. So you want to also kind of have a good distribution so you can search faster. We need extra space for 2 parities instead of 1. So instead of having 4 blocks, we now have 5. So really 2 got used for parity and the remainder is our data. So we have extra backup in case we have 2 failures at this, no, 1 failure, right? And now, so one of the downside is every time you update your data, if I want to write some data here, what do I have to do? I have to write it here, and then I have to change the parity and the parity here. So I have to write it in 3 places. But the good thing is I can read and write simultaneously. Well, actually that's not true. I write the data here, I have to read this one and read this one to figure out these. So it does make the writes take longer. The reads, when you're searching for something, are the same speed, just the extra parity means that writes take longer, but your data is safer. So those are the advantages. Okay, and then from a top-down point of view, if you really care about safety and you don't mind spending the money to duplicate all of your storage, you could have the best of the RAID 0 and the RAID 1. They call it RAID 10, but it's really 0 and 1 combined.
Yeah, I heard
It's
of
not,
that one.
it's not really 10. But basically, on this RAID 1, you've duplicated all of your storage. These are the odd numbers, and these are the even numbers. You have 2 copies of everything, so if you lose an entire disk drive, you could just copy this one over. And you can search 1, this one can search 1 while this is searching 3, while this is searching 2, and while this is searching 4. And then if that search, when that one's done, you can do 5 through 8 in another sweep. So high speed, very safe, you're not going to lose your storage, and high speed for searching. Costs a lot of money. So when you, so have you ever in your cloud project, did they ever ask you, what would you like? It's interesting. If you ask for RAID 10, your monthly bill's gonna go up, because you're asking for a lot of storage, but maybe your storage is very important. But when it's free, your bill doesn't go up, right? In your student copy, did you get a monthly bill and then they said don't pay it? Like, did they say?
The bill only comes like if you have to pay for it, I think.
No, like,
But I didn't get like a monthly statement or.
like a statement that you don't have to pay, do they have that, or?
I did, it does show it on, you don't get emailed it,
Right,
but it shows on your dash.
okay,
Like the first page you open, you know, after you log in.
right, okay. Yeah, it could be interesting if you start requesting, just unnecessarily
Yeah.
expensive storage and then just watch your bill go up, I guess Amazon wants students to use it for free, so when you graduate, you buy it.
Well, it just depends on the configuration you want.
Right.
Right out of the box.
Right, so sometimes they'll do it for you.
Yeah.
They're watching how much
Just
traffic.
for like an entry.
Yes.
Like you start with entry, but if you needed more,
Yeah.
then you know you have to purchase more, then things will get complicated after
Right,
that
right.
as
Yeah.
how.
Okay. All right, that sounds good.